All right, so this is a bit of a weird one. We want to integrate, we want to find the primitive, so we're integrating with respect to x. But that's pretty hard to do at the moment, so I would say let's make a substitution. The weird thing for this one is, though, that a substitution, you could try a few things. You can always do it in different ways. But for example, if we let u equal root x, so root x being x to the half. So if u equals that, what does du equal? Du equals a half x to the minus a half dx. Now, if we look, as we often do, we can just look at, this part. And if we look at this part, we're looking for a dx on 2 root x in here, in the integral, and we can't see one of those. So the other way to look at it is to times it and look, instead of making du the subject, make dx the subject. And you can see, remember, root x is u, so if I change this root x to u, it would be 2u du equaling dx. So we can always do it that way as well. So you can see, instead of dx in this integral, so dx is at the top, I'm going to put 2u du. And instead of x plus root x, I'm going to do it in terms of u. So x would be the square of that, so that's u squared, and root x is u. Now that simplifies nicely. So I could put the 2 out the front of the integral, and then I've got u on u squared plus u. So let's divide everything by u. So I'll just get du on u plus 1. Now 1 on u plus 1, that's a log. That's nice and easy. So we get 2 log of u plus 1, the denominator, plus c. And then, of course, we put it back in terms of x. So u is root, so we don't actually need the absolute values because root x has to be positive. Plus 1 plus c. And that would be your answer.